What's up, friend? In this tutorial, we will try to look at the concept of redirection and pipe in Linux and Unix. So the first thing is, what is a file descriptor? So you will come across this concept and terminology many times. So file descriptors are integer numbers in Linux and most of the Unix distributions, which represent a kernel data structure to associate a unique file with a corresponding integer numbers. So what it means is, by default the system will assign one integer number to each of the file you open, and with that integer number you can do any kind of operation. So if any one of you have done some system programming or C programming, they will know what is the return value of the open system call, OPEN. So when we do the shell script is also basically nothing but a wrapper on top of all the system calls. So shell script also uses system call, so which means they use the similar terminology. So that is the file descriptor, and we will look how we can use this. Now, as I said, that file descriptors are associated with the open file. So by default, the system creates three global file descriptors. One is 0, which is steady in, standard input. So if you type some input from the keyboard, like let's suppose your program asks for some input, enter how many vegetables or how many quantity of fruits you need. So you enter some number, and when you're typing those on terminal, so there is a file descriptor associated with that. That terminal input goes to the variable you are using, read or some variable, it will go into that, excuse me. So similarly, there is a steady out. When you say echo hello and you see on the terminal the keyword hello getting printed, so how it gets printed, how does it knows that it has to be printed on this terminal and not maybe on some other terminal? So it associates a steady out descriptor for that terminal. And the last is stderr. So just to differentiate between std out and stderr, sometimes there are a lot of steady out, like logs files might be outputting onto a terminal, and then simultaneously there are some errors that also gets output onto a terminal. You will not be able to distinguish between std out and std error only if they have a different file descriptor. So that's why we have a different file descriptor for stdr. Now apart from these three, you can create your own file descriptor, but these are the three standards. So if you open a file, you will not get a file descriptor as 0. You will get only starting from 3, because 0, 1 and 3 are always reserved for any process. So those three, std out, std in, stderr, are always reserved. Now let's see some of the redirection thing. So if you look redirection greater than sign, it means that redirect to a file or std out. Now std out is also treated as a file because it has a file descriptor associated. So we will say it's redirect to file or std out. Similarly, when it's a less than, which means you input from a file. Input means user input some data by hand, by manually typing onto the keyboard. And when we have less than, which means that you append rather than overwrite. And similarly for greater than, which means whatever output is there in a file, you are outputting to a file, so you don't each time override with the new content. What you do is you just keep on appending at the end of the file. So in terms of numerical values, whatever we have shown, like greater than sign, so when we say 1 greater than file name, now we know that 1 is associated with std out. So remember, 0 is std in, 1 is std out, 2 is stderr. So when we say 1 greater than file name, which means redirects std out to a file name, and then this is the same thing but it's a append, so which means you keep on adding at the bottom of a file or std out. Even though for std out it doesn't make sense, because once you have thrown an output to a screen, it doesn't make sense because that will still be visible whether you append or you just overwrite. But for a file it does make sense, because suppose you have outputted hello world into a file, and the next time you are outputting as here redirection, maybe hi there, so hi there will override hello world. So when you open the file, you will see hi there, hello world is gone. But if you use greater than, which is an append, so if you open the file, you will see hello world, and then on below line you will have hi there. so which means it's an append mode. Same thing here with 2. So 2 is stderr file descriptor, and so 2 greater than file name means redirect stderr to a file name. And when we have this special symbol called ampersand greater than file name, it means redirect both the stderr stdout to a file name. So everything whatever is there, just redirect to some file name. Then there are another important concept called as dev null. So dev null is a special character device which is default created in the system, and the useful of this dev null is like it's like a black hole. Any data which goes to a dev null is lost. So why do we need it? Sometimes you want to discard some data, like for example you want to kill a process, but it might happen many times that process is already being killed or doesn't exist. So when a process doesn't exist and you want to kill it, it will throw some error, and you don't want to show those error messages. In those kind of places, what you do is you redirect the kill value, kill -9 or minus int, with some process ID and redirect to dev null, which means even if the process doesn't exist, it will not throw you the ugly message that process does not exist or PID doesn't exist. So now let's go through some of the examples which we have discussed now. So let me do the first thing. So let's do a basic command ls-l, which we all know gives you the listing of a file or directory. So I have this listing. Now if I want to take it into a file, so as I said, by default this goes into stdout because you are able to see which is standard out. It's coming to a terminal. So it shows on terminal. If I want to take it into a file, so I will say file name.txt, any file name.txt. Now you see, imagine after this there is no output onto a screen, everything went into a file. So if I open this file with the vi, and you will see that I have this contents listed. So everything whatever was thrown onto the stdout goes to a file. So far so good. Now let's suppose I want to create an empty file. So this is when some output is going to a file. If I want to create an empty file, I can say file name or maybe something file name 1, because file name already exists, so I say greater than. Now if I look into this, there will be a file name 1 which is empty file, 0 size. So there is this shorthand notations. If you want to get rid of all the contents from a file, you can just say greater than file name and it will create. If you want to do for this file, it will just remove the content. If the file doesn't exist, it will create a new file like this. So this is about file name. Now let's suppose we already have this file name. So let's open this file name again, which we have created with the listing, and the end line if you see has a file called test9. Now let's suppose what we do is we echo something, echo hello maybe, and then we say greater than, which means append. So what append means is whatever is content is there in the file name, don't overwrite, just on the new line write one more hello, and by default echo prints into a new line. So if you do like this and try to open a file, what it will do is it will say hello with all the other contents remaining as it is. Now what would happen if you just say with a single write and maybe hello 1 2 3. Now if you open the file, you will see that only this is there. So this is no more in append mode. So single greater than is just write whatever is there onto this file, so it will overwrite everything. Double greater than means it's an append, so whatever is there just preserve and write at the bottom of the file. So that's the difference between append. Now let's suppose when we were doing this command ls-l, it was printing into the stdout, and then we used to take it into file. Suppose we don't need this information, we might be doing some operations and we don't need to see this because you're running it as a shell script. So you might say redirect to dev null, so it just goes to a dev null and it vanishes. And mind it, if you look into a dev null, it's not a regular file but it's a character device. So a C in the beginning means it's a system character device. It doesn't have size, it has a minor number and a major number for device operation. So what it means is this cannot be getting full. So don't expect that, oh, if you put so too much contents into dev null, it might get filled or something like that. No, it will never get filled, and you can dump the data as fast as possible, maybe tons and tons and GBs of data per second. It will never get filled. So just for knowing, you will never be filling up those much data, but I just wanted to point out that this data will never get filled. So you can put or push as much data into dev null and it will always be discarded. The other thing is, let's suppose I wanted to do something like this, ls minus l, and I want to check if a file 1 2 3 4 5 exists or not. So you see this file doesn't exist and ls tells me, oh, no such file or directory. So what this effectively means is, this message which gets printed on the screen is coming to stderr, not stdout. So even though it is outputting onto a terminal on your console on your xterm, that doesn't means this message is coming to stdout. So this message is coming to stderr. Now let's suppose if I try to take this message into a new file, file 123.txt suppose, and you see it has not gone to the file, but it is still coming onto the screen. But previously when we tried to take ls, it all went to a file. So why it is not going to a file and it's coming to a screen? The reason, when you redirect like this, that means only stdout goes to a file, but this message is printing on stderr. So a stderr is not redirected to a file. So you can do these redirections by saying, okay, so redirect to a file. So ls minus l test, and then you can say 2 greater than ampersand 1. So what 2 greater than ampersand 1 means? 2 is stderr. So what you're saying, okay, put everything to a file, but you also put stderr to 1. So stderr to stdout. So first you redirect from stderr to stdout, which is your current terminal, and then output everything to this. So remember, ls gives the output to stdout, but only when there is an error it sends to stder. Now if you do like this, you see there's no error shown onto the screen, but if you open the file, you can see this error message. So this is the way you can tap. And how do I know that this is an error message? Okay, so let's look at the error message command. So after every execution of a command, there is a success or failure message which a shell prints for you, provided the command supports it. In this particular case, you can see this error message by echo dollar question mark. Now you see, whenever the file doesn't exist or is there is any error, it will give you a number which is non-zero. Anything apart from 0 is a error message. So here it gives you a non-zero message 2, which means this is an error, and this throws to stderr. Now if I say just ls minus l, which means it's a generic ls minus l, it prints out everything in that particular current directory. And if I do echo dollar question mark after that, it's zeros, which means it's a success. So that's why all these messages which it prints as part of listing of the file, it's printing on stdout terminal. So remember, there is stdout and stderr, both prints onto a terminal, and then there is stdin which takes the input from the terminal. So we will look for more of these concepts in our next part. So thanks for watching this video, and you have a nice time.